I have for a long time been searching for applications of the philosophy of Wittgenstein, particularly later Wittgenstein, to physics. I believe I have found that application in the work of Peter Putnam, who, building on the philosophy of Sir Arthur Eddington, Everett of many worlds fame, and John Wheeler, constructed, in his private musings, the beginnings of a verbal, syntactical representation theory for quantum physics. There have been a couple of articles lately about Putnam, starting with this one in Nautilus less than a month ago. He was a relatively unknown figure who might have been as famous as Wittgenstein himself, if not for a meddling mother. Putnam was a man of contradictions. He was a student of John Wheeler, one of the towering giants of 20th century physics and philosophy. Yet, unlike Wheeler's other students, the most famous of whom is Richard Feynman, he did not go on to a great academic career. At Wheeler's side, he rubbed elbows with the greats of the 20th century quantum revolution such as Niels Bohr. As an undergraduate, he met privately with Albert Einstein to talk about Arthur Eddington's philosophy, among other topics. Eddington led the expedition in 1919 that provided the first evidence for gravitational light bending that made Einstein famous. Putnam came from great wealth, but spent his last days working as a night watchman in Louisiana. He published almost nothing but wrote a great deal, leaving behind a trove of typewritten manuscripts, some of which you can read here and here. His work was considered groundbreaking but inscrutable, filled with invented jargon. He was a gay man in a world where homosexuality was still considered a mental illness, partnered with a black man no less. Interracial and gay, he could not find acceptance for his personal life. His theories of the mind were considered ahead of their time, and his mentor John Wheeler considered him to be a genius, spending hours poring over Putnam's papers. Putnam's obscurity relates to two unfortunate aspects of his life. First, he wrote and spoke in a personal jargon which some referred to as Putnamese, which made it incredibly difficult to follow his arguments. Putnam knew that people didn't understand his ideas, and despaired of ever convincing anyone. The second was his overbearing mother, Mildred, who frequently used the family wealth to try to manipulate Putnam's career and his relationships. Because of her many attempts at bribing university officials with donations on his behalf, he rejected prestigious positions and rejected Wheeler, a professor whom he loved. Although he inherited wealth in 1972, he kept it all in a non-profit devoted to sculpture and took nothing for himself, preferring to work as a night watchman even as his fortune grew to $40 million. Afraid that people would only want to be around him because of his money, he hid that aspect of himself entirely. Killed in a bike accident in 1987, his papers were placed in storage by a friend and left there for 25 years, and might have been forgotten if not for science writer Amanda Gefter, who pursued his cold trail, gained access to his files in 2013, photographed 10,000 of pages of his work, and wrote about him for 12 years. While Gefter highlighted his theory of the brain and mind and its contrast to the Turing model of the brain as a computer, I find his underlying theory of representation even more fascinating. In a commentary on the Everett Wheeler theory of quantum interpretation, which, thanks to Bryce DeWitt, we now call the many worlds interpretation of quantum mechanics, he says this, page 4, "Physics is ultimately existential as verbal behavior in self-interaction. That is to say, the word has an existential as well as a formal status." And page 5, "Perhaps the word itself, rather than the thing or atom, is best treated as the basic existential unit out of which to build our model of the world." And later this, "Constructs built out of syntactic categories are of an information processing type. They are like restrictions on moves in a game of chess. Such game-like restrictions have an existential quality only so long as we accept them. They derive all their existence from our will, from the fact that we limit our choice of move to the allowed ones. As such, they are not objective in the old sense. Hence, it might seem that the very possibility of reaching objective categories was blocked by our presuppositions or absurd limitation to syntactic factors. If you are familiar with Wittgenstein's work, you will recognize the first two as being similar to his theory of language as the fundamental building blocks of meaning, and thereby, reality as we know it. The second you will recognize is a theory for how language gains that meaning, not from some mysterious connection to ultimate reality, but from game-like restrictions or language games. What's fascinating to me is that, while Wittgenstein was not a physicist and didn't write much about physics except as an outsider, Putnam is using this terminology specifically to critique and expand upon what we now call the many worlds interpretation. Many worlds' main deviation from quantum interpretation theories of the time is that it incorporated the measuring apparatus into the equations of quantum mechanics. Thus, it's said that if you have a wave function that includes a superposition of states of a particle, once it interacts with a measurement apparatus, the superposition does not collapse, but rather that apparatus gains the same superposition. As we all know, and Putnam avers, the brain is the ultimate, final measurement apparatus. While today the many worlds is described as a set of separate worlds which split when a measurement is made, at the time Putnam was writing 1970, it was not understood that way. Rather, it was understood as an explanation for how the observed and observer become correlated with one another. The measurement apparatus was incorporated into the wave function itself to define the correlation. This was seen as a kind of sleight of hand, a trick of words at the time. The splitting worlds was added later by Bryce DeWitt as an elaboration, similar to how Minkowski applied 4D spacetime to interpret Einstein's special theory of relativity. Yet Putnam is going in a different direction here because he isn't focused on worlds, but on what the theory says about the subjective nature of reality and how it is grounded in words and correlations between the brain, words, and what the brain feels. He suggests that, unless this can be done, E.W. Everett Wheeler may be a nice fantasy, but it remains incomplete in practice, page 7. The concept of observation, as far as he is concerned, does not exist in the E.W. theory, in contrast to DeWitt's interpretation which makes observation central to the universe. Putnam calls physics a great pile of number dust. Measurements are, after all, just numbers. Language, that is, words, give those numbers meaning, and those words are all relative to one another. He argues that E.W. theory has at its core the word as an existential as well as a formal unit. What this means is that words are not just a symbolic representation of something more fundamental, but the essential units out of which the theory and all of physics is built. Thus, physics is number dust glued to a scaffolding of words that give all that dust a shape. He then relates these words to the brain itself, a connection which he calls a gold mine. He then considers an example. In a measurement of the time of descent of a ball, we would regard hitting the ball or pushing the clock needles as an interference. This standard of non-interference is a way of ignoring the existential side of the measurement as a verbal response in the context of a ball that falls. The old point of view is that we only interfere with measurement when we use our will to affect the experiment physically, but this ignores the verbal structure of physics, which we always interfere with whenever we talk or write about it, whether mathematically or not. As we come into contact with some measurement, our brains become verbally correlated with the description of the measurement, and this forms reality. Like Wittgenstein, he is not arguing that physics or mathematics is entirely subjective, but rather that words have a specific set of properties and interrelationships that are built up from specific rules. The existential word, as only oriented via its relation to other words, is a very strange new construct. It is not directly observable any more than a sodium atom is. The existential word is a construct of reason, just as is a hydrogen atom. It is the carrier of position in an abstract linear ordering. It is not subjective. Thus, Putnam claims, if not to have solved the meaning of meaning, then to have put it on more solid footing. He explains how physics arises using game theory. As we make measurements and create words to talk about what we are measuring, we make use of heuristics. As we develop more and more heuristics, these heuristics collide, creating problems that need a solution. New theories are those solutions. Game theory explains how those heuristics get resolved by finding a successfully repeating pattern. The heuristics of the repeating paths are built up out of the identities of the laws of physics, page 32. Hence, physics is successful because its words continue to repeat. Repetition is hard to find. The only repeatable forms are those causally rooted. Murphy's law says that if things can go wrong, they will, page 37. Putnam was aware of the Wittgenstein school of thought and drew from it. As he says on page 38, formalists recognize that life is a game with words, and that all concepts have meaning only in as they affect the verbal order. Although the text is rambling and at times difficult to follow, and it is one of the easier papers of Putnam's to read, it does reflect a unique approach to quantum theory through the lens of language and language games that attempts to build a many-worlds interpretation not out of some abstract concept of world, but out of correlations between strings of words. The world itself, meanwhile, is a kind of computer processing words. And that is what reality truly is. My opinion on his work is that it is interesting but hard to understand. It is fascinating to see such a different understanding of the popular many-worlds interpretation, as ultimately ending with human verbalization of what they observe. It ignores the out-there concept of worlds and focuses instead on the world as a computer that correlates measurements to the brain. There is no such thing as observation or objectivity. He does not go to the many minds theory, which is an alternative to many worlds that is similar, but instead seems to be suggesting a many worlds model, where the singular world we feel forms from verbalization of our experiences. I think it is unfortunate that there is no mathematics in the paper, since it would be easier to understand what he is talking about, for me at least, being a mathematician. Nevertheless, I think that it would be worth working out the implications further. Is this just many minds theory but more postmodernist? It's hard to tell.